Hey everybody. Alright, so you are tasked with question 3. Um, and as you can see, my numbers are slightly different from yours, but the problem looks exactly the same. You've got two supports providing two upwards forces with a third being applied force, and two objects on this massless bar. And we're looking to find F1 and F2. So there are two conditions for equilibrium. The first is that all the total torque has to add to 0. So the total torque around A, object A, plus the total torque around B has to add to 0. And on top of that, all the forces, all the up forces added to all the down forces also has to add to 0. So we're going to look at the up forces and down forces first. First of all, this 90 newtons is going down, 60 newtons is going down, F1's up, F2 up, and 50 is up. So our up forces is F1 plus F2 plus 50 is our up. Our down has to carry negative numbers, plus negative 90 minus 60 is our down forces, has to equal 0. So just doing some quick math, you should be able to quickly see that F1 plus F2 has to add to 100 newtons. That's just solving, reworking, etc. And you'll see that F1 plus F2 has to add to 100 newtons. Basically, 150 down cancels 50 up. You're left with 150 down cancels with 50 up. You're left with A and B having to carry the extra 100 that isn't canceled with our third applied force. So put this equation on the back burner. We're going to come back to that in a little bit. So that's using our F up and F down. Now we got to look at our torques around A and B. So just come back here. We had FA plus FB equals 100 newtons. All right, so remember when we're dealing with torques for these two supports, we treat it as if support B isn't there, and then we'll do the same and treat it as if support A is not there. So, looking as if support B is not there, we've got 90 newtons trying to make it rotate clockwise, 60 newtons trying to make it rotate clockwise, and this 50 newtons is trying to make it rotate counterclockwise. So the torque around A is R times F of the 90 plus R times F of the 60 plus R times F of the 50. We also have this F2 here also making it rotate counterclockwise. So lots of different lever arms and forces we got to look at. Let's look at the 90 first. So our force is 90. It's a clockwise torque, so that's positive, and the lever arm from where A is to 90 is 7. So our first value of torque is 7 times 90. Moving right along, F2 is going to be acting 7 plus 2, so 9 meters away, times F2, but as I said, this is a counterclockwise torque, so we're going to end up subtracting that one. It's a massless rod, so we don't have to worry about the center of mass, so we don't have to think of that. The 60 Newton force clockwise, so it's going to be plus, and it's acting a total of 9 plus 15, so 24, plus 24 times 60, 24 meters times 60 newtons. And then the 50 newton is acting, it's counterclockwise, so it's minus. And we've got 24 plus 11, so that's 35 meters is our lever arm, times our 50 newton force. We can simplify. We get torque A equals 7 times 90. I could do 7 times 90 plus 24 times 60 minus 35 times 50. So all I did is that doesn't have a variable, this doesn't have a variable, and this doesn't have a variable. So I can just do all that math together, and I get torque A is 320 minus 9 F2. So the torque around pivot point A is 320 minus 9 F2. And we're going to hold on to that for a second. So let's rewrite. The torque around A is 320 minus 9 F2. And again, that 9 came from the distance 7 plus 2 meters from where pivot point A was to where F2 was acting. We're going to do the same thing for torque around pivot point B. So we treat A as if it's not there, but the force is still there. We just treat it as if it's not being supported. And I'm going to go a little quicker. B from F1, it's clockwise, so that's good. So we get 9F1. The 90 is 2 meters away. It's a counterclockwise, so it's 2 times 90. 60 is going to make it go clockwise, so that's a positive, and it's 15 meters away, so 15 times 60. And 50 is making it rotate counterclockwise, so it's minus, and we're 15 plus 11, so we're 26 meters away from our 50 Newton force. So you should have 2 minuses, 2 pluses. And simplifying that a little bit, minus 2 times 90 plus 15 times 60 minus 26 times 50, I get negative 580. Minus 580 plus 9 F1. So I have torque A and I have torque B, but our total torque is the torque from A and the torque from B. So our total torque is really torque A plus torque B. All has to add to 0, one of the first equations we wrote. So torque A is 320 minus 9F2 plus negative 580 plus 9F1 has to add to 0. And I'm just going to solve that. So 320 minus 580 is negative 260 minus 9F2 plus 9F1 equals 0. I'm going to skip a couple steps, but you will be able to quickly find that we're going to get F1 minus F2 equals 260 over 9, so 28.88. 28.89 newtons. So I skipped a step, but that's just a little bit of algebra. Essentially added 260 to both sides, divided, factored out the 9, and then just reordered F2 and F1. If you have trouble with that, you can ask me in class. But we get an F1 minus F2 equals 28.89. So these torque equations give us another equation that just looks at F1 and F2. But remember that, well, first of all, this could have hundreds, thousands, millions of potential things. We could have F1 is 29.89 and F2 is 1. We could have F1 is 100, 28.89, and F2 is 100. So we get a system of equations when we go back to one of the first ones, which is when we looked at the forces. And if you remember, when we looked at the forces, we got an equation that said F1 plus F2 equals 100. So this equation comes from the forces, sum of all forces, so you're just adding them. This one comes from the torques. And we get this nice system of equations that'll help us to figure out what F1 is, and then simultaneously what F2 is. So I'm going to clear this out, but rewrite those two equations. We had F1 plus F2 equals 100, and we had F1 minus F2 equals 28.89. Couple different ways you could do this. You could solve this for F1, so 28.89 plus F2, put in that into the first equation, etc. My preferred method, just because I think it's a little easier, is since you have a plus here and a minus here, if we straight up add these equations, like legit add column for column, we actually get rid of the F2 because, well, F1 plus F1, that's 2F1. F2 plus negative F2 is 0. So 2F1 plus 0, so I don't have to write that, equals 128.89. 128.89. 0.89. This is just a different way of solving a system, especially when they're a system as simple as this. And for all these problems, you're going to get a system as simple as this. And then a lot of you will see right away that F1 is 128.89 divided by 2, so 64.45 newtons. So F1 is 64.45 newtons. And then now that we know this, we can come back up to the first equation to solve for F2. So F2 would have to be 100 minus 64.45. Again, that's simple math. You get 35.55 newtons. So you've got F1 pushing up with 64.45 newtons, F2 pushing up with 35.55 newtons, and F3, or this applied force, of 50 newtons. Our total up is 150. 64.45 plus 35.55 plus 50 is totaled with our is canceled with our total down. 90 plus 60 is also 150, and we know that because we also balanced all the torques. So, looking at all that, you solved a balanced equilibrium problem, which is awesome. You will have to take this information tomorrow. You're going to get another problem very similar to this, very similar to the numbers you saw, you have in your equation, or sorry, your sheet, and you're going to be teaching this to your classmates. They had similar problems where B was located maybe on the other side, and they're going to help you with those problems, but you're going to be responsible for helping them with this type of problem. So make sure that if you have to spend an extra time and go through this, make sure you can really talk through the steps of this type of problem, because your fellow classmates are going to be relying on you. So we're going to spend some time in class tomorrow, Wednesday, doing these types of problems, sort of learning from each other, and this is the last step before our test. So good job, and if there's any questions, feel free to ask me. All right, bye.